batteries have a positive and negative terminal. And if we connect those, electrons will flow from the negative to the positive side. We call this flow of electrons current. The difference in electrical charge between the sides of the battery is called a potential, which is measured in voltage. This potential is the voltage that batteries are named after. If we have something in between, we can use that flow to do work, like lighting a light bulb or powering your cell phone. This ability to route electricity is what allows us to harness it. But other substances besides wires are able to conduct electricity too. We've all heard that you shouldn't be in or around water in a lightning storm. This is because ionic solutions in water are able to conduct electrons. But what's an ionic solution? Well, water on its own isn't conductive, but water in nature or in your tap is almost never pure because there are small amounts of dissolved minerals and chemicals present. The water in your sink has likely been treated and often contains fluoride ions, which are good for your teeth. For those who have tried well water or spring water that hasn't been treated, there are other ions naturally present in the groundwater, such as calcium carbonate. There are also likely dissolved salts, like sodium chloride, which we know is table salt. Regardless of their source or what they are, many of these compounds will dissolve in water into their ions, which are positively and negatively charged. The water molecules help to stabilize these ions and prevent them from recombining. Instead of electrons moving through solution, we have a layer of ions at each wire that are able to accept or donate an electron. This allows the current to flow. These chemical reactions occur on the wires we place in solution, which are collectively called electrodes. The positive electrode is known as the anode, and the negative electrode is known as the cathode. The two main reactions that occur are called oxidation and reduction events, or redox reactions for short. Oxidation is the loss of electrons, which occurs at the anode. Reduction is the gain of electrons, and it occurs at the cathode. An easy mnemonic device to remember these is oil rig, which stands for oxidation is loss and reduction is gain. Using electricity to drive these reductions and oxidations is known as electrochemistry. By placing the chemicals of interest into our ionic solution, also called an electrochemical cell, we are able to perform electrochemical reactions. For instance, in the image earlier, we showed sodium receiving an electron and chloride losing an electron. In a real electrochemical cell, sodium wouldn't actually receive that electron. Instead, the electron would be transferred to water. When two electrons are transferred, we would create two negatively charged hydroxide ions and a molecule of hydrogen. Unlike the sodium, the chloride would indeed react and lose an electron. As soon as two chloride ions each lost one electron, or 2 electrons total, these newly oxidized chloride atoms would combine to form chlorine gas. These two separate reactions, the reduction of water and the oxidation of chloride, are called half reactions, or redox half reactions. For every electrochemical reaction, we have to have a balanced set of half reactions. For instance, in the reduction of water, we see that on both sides of the arrow, we have 4 hydrogens and 2 oxygens. In the oxidation of chloride, both sides have 2 chloride atoms. To get one full reaction, we combine both of these redox half reactions. Once combined, we need to make sure that the electrons on both sides are equivalent too. As you can see, just like how we added and removed electrons in the animation, the net change in electrons is 0 because there are 2 on both sides of the arrow. And voila, we have a complete electrochemical reaction. Today, we are going to be performing an electrochemical reaction by connecting a 9-volt battery to an electrolytic cell. Now ideally, we could choose the exact species that undergoes redox chemistry at the electrodes. That being said, chemical systems are complicated. But I hope this video has given you some insight as to what an electrochemical reaction is. Good luck!